If this were an equation and we were graphing it, I would tell my students to start right here at the y-intercept. That's where the graph crosses the y-axis. So I'll put a dot at -2 on the y-axis. And let's see, my thing isn't catching up. There we go. Okay, and then the slope is the number, the coefficient in front of the x. Well, there's no number, so it's an invisible 1. So our slope is a positive 1. That means every time we rise 1, we will run 1. Up 1, right 1, up 1, right 1. And that will continue for the whole line. And then we can also go down 1, left 1. So this is very similar to graphing an equation. However, this is y is less than x minus 2. So what you're going to have to do is pick a point on each side of the line that you just drew. Actually, I'm sorry, I should also first say if it's a less than, I should write this down here. If it's a less than or a greater than symbol, you're going to use a dashed line. And then if it's a greater than or equal to or less than or equal to, it's a solid line. So I always say solid line underneath, solid line on the graph. Okay, so here you can see that we have just a regular less than symbol, and therefore it's going to be a dotted line when we're putting it on our graph. So let's actually do a dotted line here. And that means that if an ordered pair is on the dotted line, it's not a solution. If an ordered pair is on a solid line, it is a solution. So you're going to take an ordered pair, any ordered pair on one side and any ordered pair on the other. So I think the easiest ordered pair to plug in is 0, 0. Let's plug in 0, 0 and see if we get a true statement. I'm going to take this inequality here and I'm going to plug 0 in for y and 0 in for x. And let's see what kind of statement we get. 0 minus 2 is -2. And let's look at this statement. Is 0 less than -2? 0 is not less than -2. -2 is smaller, right? So we just plugged that in and we got a false statement. And that means that that area where we shaded is not, or I'm sorry, that area that we picked where the 0, 0 is not going to be shaded. We shade where it's true. So let's pick a number clearly on the other side. Let's pick, and I can pick any ordered pair on the other side and plug it in and see if we get a true statement. Remember, our ordered pairs are x and y. So I'm going to plug in -3 for y and +3 for x. And let's see if we get a true statement. 3 minus 2 is 1. Is -3 less than 1? Yes, it is. And that worked beautifully because you should be able to pick one ordered pair on one side and plug it in, and it's not going to work. It's going to give us a false statement. And then the ordered pair on the other side should give us a true statement, and we shade where it's true. So we are actually going to shade this entire area. This would be how you graph this inequality. Any ordered pair in the shaded area can be plugged into that inequality and give us a true statement. Any ordered pair in the non-shaded area or on the dotted line will be plugged in and it will give us a false statement. So there is also a quick little trick that I taught my students. If it's set up in slope-intercept form like this, if it's less than, you're going to shade the bottom because, you know, less than sounds more like the bottom. And if it's greater than, you're going to shade the top. And if you're looking at this, this is kind of a trick, but if you're looking at this, doesn't this clearly look like the top, right? And this looks like the bottom. And we had a less than symbol to start with. That's a less than. And so that's why we shaded the bottom.